Hello everyone, I hope you guys are doing well. Join us as we perform two activities that will help us understand intermolecular forces better. Let's start. For the first activity, we needed a glass and salt. In our case, we didn't have a transparent glass, so we just used a plastic cup, but it still works just as fine. To perform this activity, get any glass available in your surroundings. Then, fill it with tap water. Afterwards, add a pinch of salt in the glass with water. Then, just observe and note what will happen to the salt in the water. Now, let us answer the following questions. What happened to the salt as it was added to the water? When the salt was added to the water, the salt crystal sank to the bottom at first. After some time, the crystals gradually became smaller and smaller, and then they eventually disappeared from view because they already dissolved in the water. Why do you think the salt dissolved in the water? The salt dissolved in water because water molecules are polar. The positive and negative ends of the water molecules are attracted to the oppositely charged sodium and chloride ions. Thus, it resulted to the loosening of bonds of sodium chloride. Does the bond of sodium chloride break? How does it happen? Yes, the bond in sodium chloride breaks. Sodium chloride is held together by ionic bonds between sodium and chloride ions. When salt is placed in water, water molecules attract the ions strongly, causing them to separate and dissolve. Lastly, do you think there are forces present between the particles of water and salt? We say yes. These are called ion dipole forces. The partially negative oxygen end of the water molecule attracts the positive sodium ions, while the partially positive hydrogen end attracts the negative chloride ions. These forces help keep the ions dissolved in the water. Now, let's head on to the second one. For this activity, we will need 3 pieces of 1 peso coins, ethyl alcohol, acetone, any type of water, and 3 pieces of droppers. To perform, put several drops of each liquid for the 3 pieces of coins as much as it can hold. Then observe how many drops of each liquid for each coin can hold. Then, record your observation on the data table. In another set of coins, add 1 drop for each liquid. Then, record the time it takes for 1 drop to evaporate for each liquid on the data table. This is the data table we have created after the experiment. As you may have observed, the water molecules held the most liquid drops on the coin. This is because water has high surface tension, which allows the drops to pile up and form a dome shape without spilling easily. The water molecules also took the longest time to evaporate. This is because water molecules attract each other very strongly, making it harder for them to escape into the air. The polarity of a substance affects the forces of attraction or intermolecular forces between its molecules. Highly polar substances, like water, have strong attractions such as hydrogen bonding. This increases surface tension and slows down evaporation. Less polar substances, on the other hand, like acetone and ethyl alcohol, have weaker intermolecular forces, leading to lower surface tension and faster evaporation.
Dili ka patilawan na tong wine.
Party na daw.
Turoy.